Hello, friends. I think you all are really doing very well. And today I am going to discuss about a very interesting topic that is known as thermodynamics. And this is also my very first new video on YouTube. And from the beginning, I want to make a clear, short idea that I am not going to discuss vividly on each and every topic. Basically, I want to mention this course is basically designed for those who are doing their masters in engineering related to mechanical engineering such as aerospace, renewable energy, mechatronics, and such and such. So I hope that you already have covered some basic knowledges regarding the thermodynamics in your bachelor's course. And this course is going to be very short and only for the exam ready preparation. So in this particular course, I am going to discuss about energy balance, cyclic process, fluid properties, heat and mass transfer, and humidity. I didn't written in such a way, like in a proper oriented way, but I will cover all of these things in upcoming days. And I want to mention that I will solve 6 to 7 numericals regarding each and every topic, just I mentioned here, that will clear your understanding how to deal with the subject in our exam. So first of all, I want to take my very first and very important topic, that is energy balance. If you don't know how to solve these energy balance equations, then you can't manage the cyclic process and regarding another upcoming topics properly. So energy balance is basically very important topic in our studies. And what is actually the energy balance? First of all, we have to know what is actually thermodynamics. So thermodynamics is the branch of the science that deals with the energy transfer and their effects on the physical properties of the substance. And here in thermodynamics, we are going to focus to produce the work. And how we produce the work? We produce work by the mean with the help of the heat energy. And here in energy balance, the energy is transferred between the system and surrounding by the mean of heat energy and work energy. So basically, the heat and work energy, we are denoting it by Q and W. So heat and work energy are not the energies, but they are the form of the energies. And they're really transferred through the boundary of the system. Boundary is nothing but that separates the system from the surroundings. And again, I want to mention, like, I don't want to vividly clear your understanding. It's what is system, what is surrounding. I think you all know all of that. It is just for the exam ready preparation mode. So now on, basically we have to deal with the heat energy and work energy. So energy balance is a concept came from the first law of thermodynamics, where it says like in a cyclic process, the total interaction of the heat energy will be same as the summation of the work energy. Like in the cyclic process, the energy will be remaining the same. That energy can neither be created nor be destroyed, but it's transformed from one to another form. And we have the energy balance equation like in the system, we might have external work on the system or work done by the system. So we have to write by summation of delta W, and we have the heat energy inside of the system or maybe produced from the system. So we have to add on that, and we can transfer the energy to the system via the material transportation or material energy. So basically, I have written down the first of energy equation, that is, energy is in the form of the work, energy is in form of the heat, and energy is from the material. So via these three mode, energy can be transferred through the system and the surrounding. And again, we have the equation, like inside of the system, we have kinetic energy, we have potential energy, we have internal energy. So in term of internal energy can be stored as form of the thermal, as form of the chemical, or as form of the nuclear. So question to question it might can be vary. So you have to deal with that. Now I want to mention there are few you have to encounter with some few questions like steady states or stationary system. So for stationary system or steady state system, these are the system that is not variable with the time, or that is not changing with the time. So for the stationary system, the kinetic and the potential, they both are zero. You have to remember that for the stationary system. Now for steady state system, in our courses we have to deal with the steady state system, and steady state system is the energy balance we are looking with the time differentiation, it will be zero. Remember that steady state system is the system is not, or the energy of the system is not varying with the time. So you have to deal with that. Remember these equations that are very, very important. And now on, I am going to discuss a question that might help you for your clear understanding. So here we have a question. I am not going to read out this question, that will be a time waste. You can pause the video and read out the question and you can solve. So I am going to solve this question step by step. Here basically we have to find out, they mentioned the cooling capacity. So this is our main purpose. We have to find out the cooling capacity, and it's already mentioned the system is in steady state condition, and I already mentioned what is the steady state condition previously. And I want to make the boundary. Boundary means I want to specify what is actually the system here. So that is our system. And inside of the system, we have air, we have the servers, we have the lighting, we have the fan. And this is an open system. So mass and energy can transfer, like transfer means it can be going outside or maybe come inside. The system is open, and it's already mentioned that the system is steady state. So we can write out the equation for the steady state system, like I already mentioned you, the system upon dt here in this question, in this form, the system upon dt is equal to 0, and we can write out the energy balance such as summation of the heat transfer rate, summation of the work transfer rate, and summation of the material transfer rate. Why I am writing this with the dot? In this equation, I written down as the form of the energy. And while I am checking with the time differentiation, so energy with the time differentiation that gives us the power. Like any type of energy, heat energy with the time differentiation, then we can might up to heat flow rate, we can write out that. And work differentiation with time, we can write out as the power. So I am writing down as the power balance equation or the energy balance equation in the steady state form. Here we can write out it will be 0. Sorry, yeah. So here, first of all, if I check that the material transfer will be done only by the air, and air circulation doesn't cool the room because the temperature doesn't change. So that's why the material transfer we can find out will be 0, because if you are looking that material transfer rate, it will be mass flow rate of the air, Cp of the air, and the temperature difference of the air. It's delta T, and the temperature is here same for both out and in. So there will be delta T is 0. That's why the material transfer is the 0. And also the walls are the adiabatic here. So only we have to deal with heat energy and the work energy rate. So here we can find out. Now we can write down the equation again. Summation of the Q dot plus summation of the W dot equal to 0. So for summation of W dot, the energy transfer rate, we can write out summation of W dot equal, we have the work supply rate from the servers plus work server rate from the lighting plus work server rate from the fan. So here we have four servers, four racks, each with 15 servers, and they are drawing the electrical power of 350 watt. So that is will be for four racks and 15 servers per rack, and they are drawing 350 of watt. So that's give you near about 21,000 watt power, like power, yeah. And the lightning power they are mentioning as 160 watt, and fan power is 240 watt. And I want to mention one thing here, like when you are adding heat to the system, then you have to write down as the plus Q, the sign will be positive, and if the heat is removed, you are removing the heat or heat is rejected from the system, then it will be minus Q. And if you are supplying work to the system, then it is minus W. Or if the work is produced by the system or work is done by the system, then it is plus W. So here the heat is negative because we are cooling the system. Cooling means we have to remove heat from our system, then it will be cool. So we have to write it's minus Q cool. So I am making it minus Q cool, and our work rate we have calculated as 21,000 due to the server, plus 160 watt due to the lightning and due to the fan 240 watt. So summation of work rate will be uh, 21,400 watt. So I can write it here, and then you can write out Q cool is 21,400 watt or as 21.4 kilowatt. So that is the question, and basically the most important fact I want to mention that we have solved here, that is the ultimate answer 21.4 kilowatt. And I want to mention a very important topic like the negative signs I written down here is very important because heat is removed from the server room, and the magnitude you have to write while you are writing q dot cool will minus 21.4 kilowatt. So that's magnitude will tell us the required cooling capacity. Okay, bye. See you in the next video. Thank you for now.